So, this is the 315 that I've left switched on up in my studio for some time. I play my guitar, mess about, come back, leave it switched on, and it's been reliable. Probably up there for 6 months, and I've left it on for 3 or 4 days at a time, just idling, because I forgot to switch it off. I assumed it was fine. But I do repair these for a living, okay, so mine's been fine. And I bought this originally years ago. In fact, it's probably the first time I'd come across the 315 speakers and the 515s. And anyway, so I was up there and I was learning a new song. It wasn't plugged in through the PA at all. It was all quiet, and I was just looking at the music sheet, and then a huge bang came out of one of the 315s, this one. So it was idling, there wasn't any cracks or bangs from anywhere else I could take. It had just chosen that moment to give up, and it went bang out the speaker. No smell of burning, nothing else, no lights on. Now it's completely dead. So, having repaired loads of these for other people, it's now time to repair my own. So let's have a look at it, shall we? What we need to do is to remove that from there. We can get rid of this part at the moment. It is wired in still, connected here, but only the mains. So let's just shove that out of the way, because I don't think it's the input unit and mains input. And what you have to do is to remove this cable from the tape, whip out these, if you can find the right screwdriver, whip these screws out, all 4 of them. Actually, while I've been taking these screws out, I realised this isn't the one I repaired. There was 2 I bought from the same person. One was faulty and one wasn't, and they were second hand. And this is the one I haven't touched, and I'll tell you how I know. Is because A, this tape hadn't been taken off before when I took it apart, I just realised, and B, this one has been sealed down. The can has been sealed on with silicone all along this edge. Look, can you see that silicone? Which is something I don't think I've ever seen before. So I've taken the screws out, and if I just slice that silicone, hopefully the thing will be able to lever off, all things being equal. And let's have a look inside, see what we've got, shall we? See what awaits us within. What I'm going to do is repair this, and I do these repairs for a living, but these are at the bottom end of the equipment that I repair, and it's virtually on borderline whether it's worth my while, to be honest. So, and I get emails in from all over the world about these, and on a few of them I've given them the circuit diagram and said go to a local repair shop, because by the time you've shipped it across and we've fixed it, it's not going to be worth your while. But we've had a lot from Africa and Europe, France in particular, so yeah, apparently it is worth repairing them. But they are very good speakers. So that's the can. The can has now come off with this silicone on, so let's get rid of that. And there's the actual controller, power control, power board. Very good while it lasts. So here's this horrible sleeving they stuff on, look. And that's interesting. The can you see this horrible mess they've made here, look? On the later ones, they've got, or the earlier ones, I'm not sure if this is an early or late one, I'm guessing this is a fairly early one. They have spade connectors on here, and this is connected by spades, but actually on this one, they seem to have been soldered, and then a great daub of horrible glue gun glue has been stuffed on there. That's just what you want from a very expensive piece of equipment, isn't it? Real attention to detail, boys. Bloody joke, isn't it? So I can't just unplug it. I was expecting to be able to unplug that, but let's just have a look at it anyway, see what we've got, shall we? So, output transistors are underneath these various screws. There's devices on the board underneath. If I just show you that edge, you can see those 2 components in there. A couple of output transistors, I think, under there. I can't quite remember which ones are which offhand. without looking at the back side of them. So this is just a piece of sleeving that goes onto a header where the auxiliary ribbon cable. You've got your LNK30, which one is that? I'm just going to read that part number back. Yeah, so a pointy thing to point with, a pair of tweezers. You've got your LNK302, which is your offline power supply chip, and that provides a 20 volts or about, I think about 17 volt rail to run all the electronics for the high side of the power supply, i.e. the main side, the non-isolated side. And it basically takes the rectified output from the mains bridge rectifier. Is this universal, this one? I can't remember whether these are universal. Some are, some aren't. Yep, so it's a universal input. So there's the old switching relay down here which switches in the voltage doubler. So there's a detection circuit that detects whether you're running on 110 or 220 and then switches in a voltage doubler or doesn't appropriately. That's the theory, that's not the practice. And then the rectified mains goes onto these big smoothing capacitors. There's two big smoothers, 200 microfarad, 200 volt, 1200 microfarad each. So they're quite substantial capacitors actually, with this piece of tape on top, paper insulated to stop it shorting on that can. Okay, so get back into the picture. And what were we talking about? LNK302, disastrously horrible chip. If you see it, change it. That's what I'd say. If you see a 302, 301, 304, just change it, because if you're giving a warranty on your repairs, the chances are that thing is about on its last legs. They seem to have a finite life as far as I'm concerned. I've come across them in washing machines, I've come across them in lights, I've come across them in hospital sort of bedside units that provide a little light for the hospital bedside. I've come across them in Aerochino milk frothers, the early version, and they actually, in the later version, they've designed this chip out and put a national chip in instead. So the combination of this chip, that capacitor, that diode, and this buck coil and the smoothing capacitor takes the 300 odd volts from the raw rectified mains and then produces the 17 or 18 volt supply to run all the electronics, the management chip and the bridge driver circuitry for the NMOS power FETs, half bridge here, look, see? And instantly, just by looking, look, this little fella there, that is a diode, I think, in the gate driver circuit for this FET that's underneath that, isn't it? There's the three wires in the half bridge. There's a very large resistor there, that transistor there. I'm not sure if it's a Darlington drive on these. I can't quite remember actually. I normally just go through and give them to an operator to change the components. They put a white spot on there and they swap them out and give them back for me to test and debug. And then you've got your gate driver chip and your management chip, I think. But clearly this one, it's either generally it's the low frequency drivers gone or the high voltage input switch mode power supply, half bridge, resonant tank circuit. This is a resonant tank circuit. Actually, maybe it's not a resonant tank circuit on this one, but here's a transformer. Yes, it is. There's a capacitor there. So, yeah. So these FETs have clearly gone. These have gone. That's gone. That's gone. That's gone. So what I'll do is I'll just do a really quick video just showing you what these values are and which ones you need to change when you do a repair. And generally, if you just change all those components, it'll work. All right. I mean, on the power side anyway. So let's have a look. While I'm at it, actually, these people that, if I can find it, it's around here somewhere, because I had it the other day. When you're running these JBL speakers, if you're on the end of an extension lead, if you're in a remote location, or if you're somewhere where there's a lift and not a very good power supply to the building, or there's lightning about, or your domestic supply is not good, there is advice I give, and I've been doing this, is to connect your JBL kit at the socket where the unit's plugged in with one of these. I'm going to zoom out and show you this, because take it or leave it, but it's the best piece of advice you'll get today, probably, is this thing is just a box full of, is there one in here? Do you know what, I can't even see one in here. There must be one, mustn't there? They can't have left one out, that would be completely stupid. Surely not. Well, I'm going to check on that in a minute. I thought there was a varistor in here, a surge arrestor basically, voltage dependent resistor that conducts when you get a transient, high voltage transient coming down the mains. That thing is a Ptc thermistor. Yeah, that's the Ptc thermistor, not an NTC. You'd think it was an NTC when the surge comes in, but it's actually a Ptc, and this relay switches that out when the unit powers up. Okay, so if this relay is broken, when you power the unit up and start playing some very loud music, it keeps shutting down because this heats up and then finally goes open circuit and then starves the unit of power and it resets. Okay, so that's PTC, but normally there's a varistor in these things. Do you know what? I've never noticed that before. Anyway, I digress. What I'm saying is, because of the lack of protection on the input of this, which has caused that, use one of these. Alright? They're about $10, and ignore the 13,500 amps, but there is a much more robust protection inside this than you would ever get inside the power supply. And clearly, if there is slightly dicky power supply, then you're going to have a problem with your unit blowing up, and it's an expensive repair. So get one of these and use this. They do various, they do US and EU socket versions. This is the one for the UK market. It's about £6. But I've got in my kit, I've got 3 or 4 of those, and I just plug everything in with it. Especially if you've got an extension lead, because if you're down the end of a line somewhere and something else is plugged in, you can get some pretty evil transients being generated. So use one of those if you can, because it will protect your JBL kit. Okay, so that's that done. Chuck that out of the way. So back to this. Yeah, so I'm going to knock on and just do a quick video of what to change on this, and then I'll change them, and then we'll retest it and I'll show it working. All right. Right, boys, it's no sense being an optimist when you're doing switch mode power supplies. When you turn them back on, the magic smoke is instantly released unless you are thorough. Okay, I mean, these have obviously destroyed themselves. We haven't looked on the back of the board to see what state these FET's in, but maybe the package is even blown apart. Okay, so you've got to change enough of the stuff to make sure that when it comes back on, that all the stress components have been changed. Otherwise, let's go fut and you'll be back to square one. Having worked on a production line where the engineers made, I didn't work there actually, I ran the operations and the development department, but constantly when we had a catastrophic failure in a power supply, people would not change enough of the components, plug it back in and go fut again. And you can't tell by metering with you can obviously tell dead shorts, but you can't tell damaged or compromised semiconductors or internal components that have been damaged inside the chip. So you're going to have to change them, and we're talking about £5, $8 for all the parts, and consider the time you'll take debugging and changing, getting frustrated and not really having much fun at all. You might as well change it. Alright, so you got these R626 and R628 at 10 ohm resistors. These two, this one and that one, need to be changed, and that's what they are. They're 1210. Alright, from Farnell or similar. You can see the manufacturer's part number down there, but obviously the equivalent will work. Alright, so that's that one. Change those. The second thing you'll have to change is the FETs underneath the board. There's 2 FETs. You can see their legs sticking up there. Okay, they're trench stop FETs. Quite good ones actually. They're supposed to give you symmetrical turn-offs and things like that, and give a low component count and low EMI radiation and better efficiency than standard N-channel isolated gate FETs. So that's those. Have you got it? Good. Change the FETs. And what have we got next? I've sorted these parts out just now, just for you. Right, so we've got this fella here, him, LNK302, and that is U608 by the look of it. That's him. Got it? Now we've got the, I was wrong about these actually, these aren't the diodes. On the other circuitry they use some diodes and a different driver chip, but this one's got this MX7380 driver chip, half-bridge driver chip, and these two transistors. These are a Darlington pair of transistors supposed to increase the drive capability of this chip, driving into the capacitance of that gate and switch it on and off very quickly. Obviously if they both turn on at the same time, then you basically have a, well, if they're in series, it'll be a 1100 microfarads directly dumped at 350 volts across both FETs, and this is what happens when that happens, okay? If they both get switched on at the same time. So this circuit here, its job is to ensure that they are switched correctly without having crowbarring the actual supply rails. So we've got this one here, Q603, which is the KSC3265 NPN transistor, K1Y, so KSC3265. That's the NPN part of the complementary circuit, for complementary pair that drive the gate. And there's 603 and what's the other one? 625. 603 and C625, 602. That must be 625 there. Okay. So the NPN version has got KY. It's got chip ident K1Y, and that's K1Y. Just to recap, that one, K1Y, 3265, and that one there. Okay, so it's those two changed for the NPN. Then we've got the KSA 1298. Is that one there? Is that, I want that one. Yep. So this is the complementary PMP version of that transistor. All right. And that goes in this position, Q604 and Q602, and it's got J1Y on the lid. Okay, okay. So that's those. Now we have to change this chip, which is MX7380. So change that one as well. That will be destroyed. There's a 49.9 ohm resistor, which I don't know what I've done with though. Yeah, we were talking about this chip 73080MX. That's that one. Finally, there's this one here, which is the TL494CD, TL494 switch mode management chip, and that's that one there. Got it? Good. Now, what we were talking about earlier was this PTC, and I was just racking my brains. I was just wondering out. I worked this out before, but I kind of forgotten what it was for. Can you imagine what that's used for? That positive temperature coefficient thermistor. Normally, you would have an NTC, which would limit the inrush current into these capacitors from the mains. Okay, so the idea is that it starts off at 20 or 30 ohms, and it just limits the current whilst these charge up, and it heats up, and then gets into an operational mode where it's producing heat itself, internal heat, and it goes down to an ohm or something like that. Negative temperature negative temperature coefficient. Okay, but these are positive temperature coefficient, and this the power comes in through that, and as it heats up, this will go open circuit if it gets too hot, and there's a relay in to short it out to basically switch this out before it gets too hot. Have a think about that and what that's for, and then I'll tell you at the end of the video. It's a bit of a challenge for you to work that one out. You probably know straight off, but it took me a while to suss out what was going on, because I haven't really thought about it before. But it's quite a clever idea, but it does have its drawbacks. So a PTC in the power line with a relay to short it out. What's it for? Yeah, and the relay is driven by the DC voltage generated by the power supply. So I'm just going to change all those components. I'm not going to do it while you watch, really. I could do. There's other videos on my channel which shows you how to solder the chips by hand. And clearly, if you're removing things like this one with hot air, you're going to have to protect this or remove this capacitor first, because it will get scorched and damaged. Okay, so I'm going to remove all the screws, then I'll show you the underside of the board, and then I'll change the components, put it back together. Yeah, so all the screws are out. Some of them are Torx, most of them are just ordinary Phillips or Posidrive, Phillips heads. Yeah, and yeah, so I'm going to have to lever her off, I think. She's stuck on with all the stuff underneath. There you go. And I lever this off. Have I got all the screws? Have I missed a screw? Don't think so. It's just the silicon pads, the heatsink, conductive heatsink pads holding it on. You can see how stuck it is, and the rubber feet that they put underneath. Okay, so now she's loose and she's free, so I'm going to lift this off, and then you need to look under there and see how it all goes back. Now look, here's the more for the graveyard. Here's bits of trench stop gate FET casing blown off. The magic smoke came out with force on that one, and you can see these are the silicon pads with imprints of the transistors that insulate. And I'm telling you now, if these aren't in good condition, then these cans can short through to the heatsink, and when you turn it on, you'll just it'll just go off again. All right. So make sure that these aren't damaged or compromised in any way, like split, burnt or cracked. You can see, I think this one's okay. This one's not got a tear in it, but it has got carbon on it, which will be conductive, so it might need to be turned over or cleaned. I'll decide on that later on. I've got this insulating paper thing here to stop any kind of flash over or any of the pins on there sparking over onto the earth. Remember, this is grounded, and then you've got this series of bosses on there, so I'm going to shove the heatsink over to one side. That's just the mounting plate. Ooh, keep that intact. The other thing is, don't leave this around the workshop or anywhere where bits of grit or solder or detritus or trimmings can get into it, because then again it can cause you problems. Alright, so going back to this thing, this is the top side of it again, and if we just flip her over, you can see what's happened here. What's happened here? My goodness, what's happened here? Let's have a quick look. Okay, so explosive release of magic smoke. That's what happens when you get 1,000 microfarads at 300 volts plus dumped into a device. You end up with a bit of danger. You see, she's destroyed herself. She's got, oh, I can't do it anymore, and then gone. Yeah. I don't think that FET is gonna be salvageable, do you? Bang my bloody legs off. And there's the other one, but he'll be gone as well. He didn't take the full brunt like this one did, but there we are. What you do. So clearly those FETs have got to come out and be changed. You can see there's other various ones all over the board. Let's have another look, see what else we can find on here. Anything worthy of note or interest? Probably isn't. Got these pads here, these silicon pads, which again, they're that gooey stuff, and underneath there is the output transistors. Very small, special packages. I'm not going to pull those off. Am I? Or am I? Okay, I'll pull them off and show you what's underneath. Hold on a minute, it's going to macro first though. You'll have much more fun in macro. Right, this is a bit like peeling a spot. It's very satisfactory. Or a scab. Right, so under here is a couple of they are tricky to change actually. They're not my favourite devices to change. But can you see that? That is one of the power FETs in a metal can, and they look like the ones that you use on RF drive circuits for radios. Use similar. If I just pull back the peeler back, and you can see that there's my finger. So it's pretty small, and there's two of those on each channel. One on the two on the LF channels and 2 on the HF channels. And touch wood, even though this is an earlier design, these are much more reliable than the 515 output stages. Okay, in the output stage on the 515 there are 4 transistors instead of 2 on the LF channel, and the HF driver circuit is managed by a monolithic chip, you know, a TDA type D-class audio amplifier chip. But these are quite good, and I have changed them in the past, but not many actually I have seen blown up, so that's more reliable. The actual output stage it's probably lower power. I can't remember. The output power of the 515 is claimed to be 280 watts, but it's nothing like that RMS, nothing like it at all, not even half of that, because I know if you load the power supply up it falls before it's even delivering 100 watts. But they talk about music power and instantaneous power at the peak of the sine wave of the output signal. So at the peak it might be, but we used to have music power and we had RMS in the old days. Now everyone seems to quote music power, and the RMS stuff is subject to a lot of debate and questioning. Right. So anyway, that's the heatsink pads. So leave them on, don't take those off. So I'm going to go and change these components, then we'll fire her back up again. Right, so you get your tip and you give her a bit of a clean in the robot bush. There we are. Don't do anything without a clean tip. You have been warned. Okay, so here we go. We have some leaded solder, and there's the Destructo devices that have had a bad day. I'm just going to whip them out now. So yeah, plenty of heat. Put the unleaded, well, leaded solder on until they are like that, and then just grab a hold of her and pull her out. 2, 3. Where's my mother socket? There she is. While it's still nice and hot, you might as well mother socket right at this moment. Save you doing it later. And she's all heated all the way through. Oh, that was filled up again, so there we go. That's that one moved. Now do the second one. Smoke. That's Kingbo flux, by the way. I've talked about it before. I'll show you the pot in a minute. Is if you use a bit of flux, life goes better. It's like Pepsi Cola, or is it lies better with a Coke? Well, it's better. Flux is even better than Coke, to be honest. Not cocaine. Remember those advert campaigns that things go better with Coke? Okay, all this stuff will clean off with isopropyl alcohol afterwards, so just suck up your little driblets. So that's those two removed. Right, let's go over to the other side and stick it back on autofocus. There we are, and then swing. Where are we? Where are we working? That's where we're working, just down there. Right, focus. Focus, we want you to focus every day. Oh look, I've forgotten to take that cap out. This cap here, this one, that chip's got to go, right? There's the transistor I just removed, but this 47 nanofarad, if I heat everything up with that on there, it'll just melt, so I'm just going to whip that out. One moment. There we go, so let's whip her out. The legs are slightly bent over, so we might have to give her a bit of a tweak. Come on. Maybe a bit of leaded solder as well, just to reflow. This horrible unleaded solder has got a higher melting point, and it's just not as nice to work with as leaded. So let's put a bit of lead on there. Let's put a bit of lead on there. Warm my legs up and just gently rock her out. There she goes. Okay, there it is. We'll keep that, save that one for later, and we'll suck the hole out in a bit. Right, hot air gun is on, set to about 300 degrees, 320 degrees. Lighting is all cock. It looks okay on the screen, so I won't bother with that. Turn this one down a bit. Can you see that? Yes, you can. Right, so you can see all the Kimbo flux gunkers spread out nicely all over the board, all that area. All this waxy shininess is the flux, okay? And it's very essential that you have that. Makes life a lot easier. So without further ado, let's get her heated up, start taking some of these components out. A little bit more temperature, because as long as we don't scorch the board, we're going to do okay. You can see the smoke. Enough heat to melt this evil solder, evil unleaded solder. Don't have to use it on industrial stuff, you know. It's only for domestic, commercial stuff, and military is exempt. Especially at low temperatures on lead-free solder. It's tin, and tin has got an allotrope, which is a grey powder. So what happened to Napoleon's soldiers? All their buttons turned to grey dust on the Eastern Front in the Crimea, and it was the tin. And the other thing about tin does is it forms dendrites. Those little crystals grow at low temperatures and at strange temperatures, and there's electric field. And for military and satellite and stuff like that, they don't want dendrites growing across the connections in the microelectronics. So again, they're exempt from the ROHS. Not ROHS, is it ROHS? Yeah, it's ROHS regulations, which is interesting, don't you think? Or not? Maybe you don't think it's interesting. You really should think it's interesting, because it is really quite interesting. Right, it's smoky in here now. That one's hot. There we are. Whoa! Did you see that? What was that went pop? They're all to say, isn't it? It was C626, I believe. That's what can happen, boys. Check the video on that one, see what went pop just then. That's unusual. I don't remember that ever having happened to me before. There's always a first time. Waft her around, heat her up, and remove the chip. So I think that's everything. Plus, oh look, there's a component being blown off here. Where did that come from? That must be R617, I think. Okay. So the only other thing we've got to get rid of is that 49.9. Let's take that off there with that. Stick it onto the board. We'll find out where that goes in a moment, because we'll be able to see on the video where she hails from originally. I think it's that one there, so I'm going to put that back right now. Okay, so I think that's just about everything removed that needs to be changed. You need to get a meter and just check that diode is okay. It probably is. Oh yeah, and we're going to change that one as well, but I'll do that in a moment. I was going to check the video to see what self-destructed just then, and see whether R613 is supposed to be fitted or not. So let me review what we've done and we'll have a look. It was a very strange explosion, that. Okay, so let's just put these chips back on, shall we? Yeah, that capacitor that exploded was a 0.22 undefined voltage actually. It was obviously clearly a pretty good capacitor, because for the size of the case it's quite a low capacitance value, which indicates it's probably quite a good decoupling capacitor. Very little inductance or series resistance, so I'm going to make sure I replace that with something which is probably equally as good. Right, so we've got the colour change. Can you see that on the pads? Try and get my head out of the way of the proceedings here. Alright, let that cook slowly, don't rush things. Rushing things is never good. Okay, is that one done? Right, what should we put on next, boys? Q603 is the KSC. Q604 going on now. Oops, I'm thrown upside down onto the board. I have had a couple of red wines, so I'm drunk in charge of a soldering machine. It's not a crime in the UK yet. There we go, that's that one. And then we want the K1Y. Which that Johnny there, stick him on. Remembering to move this around and not to overheat things too much unless you can help it. Okay. Okay, it's a little bit low on solder, that pin there, so that might need touching. Oh no, it's flowed. It's flowed. Right, 10 ohm resistor coming on now. For the colour change, warm the component in the airstream and then drop her on like that. You see it flow? Of course, I stuck a load of the king bow on as well, which is also going to help a lot. You can see it flowing away. There we go, colour change. Can you see that? Can you see that? You can see that, can't you? So what now? Oh yes, the 7380MX goes around that way. Turn it around in your tweezers. There we go, so put it there on. There's a bit of colour change coming up. And a bit more. Drop her on. There she goes. I don't normally do this actually in the office. Stella would do this. She's a good girl. She knows all her components are. She hides them, I reckon. Yeah, it's the only way she could possibly know where they all are is by hiding them. Right, okay, so what have we got there anyway? We've got, where did the 49 ohms go? There you go, there, don't they? 49.9 ohm going on. Skunk. There we go, that's on there. Lovely job. What have we got now? Q602, which is 602, let me think. Here's a KSA, which is a KSA 602 going on now. A J1Y on the ident. Warm her up and drop her on. Let her flow. Let her flow. Let her flow. We might need to put a bit more flux on there, you know. And then the other one, which is gonna be, which one is that? It goes here somewhere. Q601, which is a KSC. Okay, so that's a K1Y again. There we are. So where's my flux gone? Let's put a bit more of the old king bow on, shall we? Yeah, I think it's getting a bit blown away, literally. You watch this. You watch this flow now, boys. Now I've put the flux on. Oop. See that? See how different that is with the flux on. It's lovely, isn't it? It's lovely and fluxy. Look, it's just lovely. You could tin the cheeks of your mum's backside with that. And then these caps going back on, the ones that exploded. We've got C626. Here's a 0.1, 50 volt. There she goes on there. And we've got C628 is a 0.22. She goes on there. And then I've knocked that transistor off, so I've got to put that back on. Let's back off of it. Things are getting a bit warm around here. And I'm just going to put a bit more flux on a couple of things. That one there looks a bit sort of dull, doesn't it? That one looks a bit dull. So does that one, and that one there as well. And possibly it's going to flux that up there. Remember, this cleans off. This cleans off nicely with a bit of the old isopropyl alcohol or isopropanol. Now look at it now. Isn't that shiny? Doesn't that look much better with a bit of flux? Things go better with flux. Ooh, yes, it does. And then this one here looks a bit. There we are. Look at that. Beautifully done. Beautiful. Okay, and then let it cool down slowly, 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 not too fast. Just whisper away. And that, gentlemen, is how you do that. There's my head in it all the time. I bet it was. I bet you got a big picture of the top of my bonnets rather than all the soldering. So that's that one. Hope you enjoyed it. We're ready to rock and roll. Actually, no, we've got to put the FETs back in, but we've got to put the trench FETs in, but otherwise we're fine. Okay, guys and girls. Yeah, when the device blows up, when those FETs blow up, it shoves the 300 volt rail straight back down the FET driver chip, straight down to the power supply management chip, and straight onto all the other logic chips which are attached to that supply rail. So you're going to have to change basically all the semiconductor chips in the power supply. The other two that you need to change, which I hadn't covered in the other section of changing, but I've changed them now, are this one here, LM393, which is U601. U601393, that's that one. See that? That's from RS. Is that going to focus? Yeah. Okay, so you've got 5361388 from our radio spares, or RS as they're now called. They don't do telly stuff anymore much. So that one, and the other one is this little flip-flop down here. That one there. That one checks everything's all right before it powers up the power supply. It's to do with the universal input power supply. Okay, this power supply is too powerful really for an auto-ranging one, so there's a voltage doubler and a sensing circuit and other electronics linked to this relay you can see just there. And that one there is this chip. Focus your focuser. That one's from Farnell, farnell.com, and ooh, what's the part number? It's 1468778, 1468778, and the actual, that's the manufacturer's part number there, right? So you're going to have to change those two as well. No way around it. It's a bit of a fag, but if you don't change it, you'll end up poking around and blowing things up and then changing them anyway, possibly changing everything else again. So do it first time round. That's my advice. Alright, so just to recap, we changed all the other components. We've changed LNK302 has been changed. This has been changed. That's 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 been changed, that's been changed, that's been changed, that's been changed, that's been changed. Anything else been changed? And then over here, that's been changed and that's been changed. Alright? Careful you don't dislodge any of the components when you're changing them, because you... my advice is to actually take a really good... I don't know if this video's got enough information in it, but if you take a really good high-def picture or anything before you start working on it, if you're not familiar, then if you dislodge a component or you put some solvent on and the ident disappears, you've got a photographic record of how it should have been before it was touched. Hopefully it hasn't been buggered around with by another engineer beforehand. Right, so you need to change all that, okay? So he's about ready to put that together. I've just cleaned off all the guts of the exploded trench stop transistor, carbonizes pad. I have no idea whether it will short out or not, but there's a lot of carbon and detritus, so I've just used some IPA and a toothbrush to clean it up. So up to you whether you do or not. So that's what it should look like. That's what the whole plate should look like before you stick the unit back together. Cardboard flashover protector and heat sink pads here, here and here. Okay. Bits of horrible silicon everywhere too, but that shouldn't necessarily be there. Alright, okay, so I'm going to put it back together. Another thing you should just check, these are the new trench stop diodes that have been put in, and generally on all these JBL range you have these transistors mounted onto silicon pads, okay? Power devices and diodes as well on the 515, but You need to check there's no burrs on them, because I've had them where I've just put them back together and there's been a slight burr where this has been manufactured and it's punctured through the insulation washer, the conductive silicon pad on the heatsink, and then shorted to the heatsink. And I've had that a couple of times on these, and when I looked at them, it was a very sharp edge on one of these that punctured through. These are okay, but just watch out for that, because it does catch you out, especially on the 515, because they are screwed down mighty tight. And you almost wonder whether the tightness of those screws actually is good for the components, to be honest. It's a little bit on the tight side. I prefer to put a bit of Loctite on the threads and just tighten them down moderately tight, and then let the Loctite hold the screw rather than relying on the tightness of the screw to hold it in position. But it's up to you, but look out for burrs anyway, because they'll puncture the silicon washers. Now when you power up, if you listen carefully, if you've got voltages, for example across this capacitor here should be, but across this capacitor, be careful, this is reference to mains, alright, this is an offline power supply, this is the rectified mains low voltage, so it's a 0 volt AC line they call it. It's the high side, it is referenced to the mains. If you short that to ground, it will go bang, the earth connection on the plug. So but if you carefully meter across there, you should get about 12-14 volts, okay, and that means that this power converter in LNK302 is working, you've got power to your chips, and there's no shorts on this side, alright. Now I'm running through a light bulb, and a 60 watt light bulb will give you a dull glow when you put it on at 220 volts, and you'll hear a click as this relay kicks in. This is the voltage, this relay kicks in, which is the one that shorts out this PTC here, right, okay? So you'll hear a click as that clicks in, and that clicks in, that's a good sign, because there is DC, because this is driven from the DC supply, right, on the secondary side. Is that right? Yes, it is. It only fires up and shuts that relay when the power supply is running. But if you still, and if you listen carefully, and I've got actually, also, don't forget, I'm jumping around a bit here, don't forget to connect your load resistors, 2 ohm and 4 ohm, okay? 2 ohm for the bass side and 4 ohm for the treble side, right? They're in parallel. Okay, so you can see there's the resistor, 2 ohm, 50 watt. Right, so don't forget to correct your loads, otherwise you'll be in trouble. Now, if you power it up and the thing's not working, or it's gulping too much power, and I'm not sure if this is the root cause, the actual, you know, they have when they have a zombie attack, they have Patient Zero, don't they? Do you remember that film? What was it? One with Tom Cruise in. But yeah, Patient Zero is the one you want to get, and I think maybe Patient Zero on these amps, as well as the mains transient, is also these capacitors. That one there is a very unhappy capacitor, and if I pull her back again, pull her looms out the way, see, 113, and what was the other one? I can't remember now. The 113, and let me just have a quick look. I'll be able to tell from where it is on the circuit. Yeah, so it's C113, that one, and C213, that one down in there. You can't actually see it, can you? There it is. There she blows, that one. Alright, 10 microfarad, 16 volt, and they are standing in the middle of the electronic motorway with a juggernaut bearing down on them every day, and they don't like it there. They're in a horrible, stressful position, and they bugger up. They go, basically, the capacitance reduces and reduces, and that's what provides the supply for the high side drive for the FET, and it's, yeah, change them, okay? So C113, C213, and I'll flash up the part number, the data sheet. It's a Panasonic low ESR, very good quality capacitors in the aluminium tin sizes, and if you stick to those Panasonics, then you can replace anything with them. Alright, it's going to be better than what you've got. Alright, so stick with the Panasonic range. It's the E range. I'll stick a data sheet up when I get this on the editor. I can't remember what they're called now, and I've just looked in my bin, and the part number ticket has gone out of the drawer, so I know what they are because I've know what I've ordered before. But stick with, if you're replacing these aluminium cam capacitors, stick with the Panasonic ones of the range that I'm going to show you, because they are not foolproof, but they are so much better than taking potluck on one you find in the tray or ordering some other cheap capacitor. They're slightly more expensive, but boy, they're worth it, alright? I've used them in power supply designs, you know, 50,000 hour ratings and stuff. Right, so yeah, change them 2 caps before you put this back in the box. If you don't want to take it out of the box again in 2 years or 6 months or 3 days, change those 2 caps too, because they are very prone to being destroyed. The capacitance just reduces and reduces, and then you've got the output powering up, shorting out, going crazy, oscillating, and you know, constantly dragging the power supply down, constantly stressing the stuff over this side. And if you listen when you power it up, you can hear it going tick, tick, tick really carefully. If you're a bit older than me and you're a bit deafer than me, you might not be able to hear it, but tick, tick, tick is what you're looking for, alright, from around this area somewhere with the load attached. Alright, so I'm just going to change those 2 caps as well, and then we'll fire her up and see if she's going to go for us or not, alright? So, one moment. Alright, I'm going to apply some leaded solder and 400 degree iron, good quality iron. Let it dwell, let it dwell. Actually, I can keep the heat on there while I locate my tweezers, which I haven't put back in the right place. Right, okay, so then just lift one side carefully, lift one side, raise it up, don't pull it all the way, otherwise you'll rip the board off, or rip the track off the board, should I say. Now the other side. You can't really put heat round here with the heat gun because A, it takes a long time, and B, it'll scorch you everything else, and you'll end up with God knows what other collateral damage, as Americans call it. Yeah, this poor little fella's not very happy. Note which way the negative is, which going to the right. And actually on this board they haven't followed conventions because there's others facing the other way. When I design a board, I always try and make the capacitors face the same way if possible, because then it makes inspection much easier. You can run your eye over the whole board. There you go. So now heat to both sides, and there she's heated. Alright. So we take her off. Bit of solder braid, bit of the old moppy going on. There we go. Suck up the juices, as it were. Break the Panasonic cap out of the packet. Talk amongst yourselves when I get my packet open. There we are. Lovely capacitors. Look at them, they're beauties. A couple of those on the table. Right, okay, so a blob of solder on there. Leaded solder, of course, for the lovely flowability. And then CHB cap. On we go with you. Heat one side, solder it, settle it down. Make sure she sits square. Make sure you've got access to the other pad, otherwise you can't solder it. There we go. That's lovely. That's a lovely job. And now the other side. I hope my hair isn't in the way again. I keep doing that. I'll have to get my hair cut off, I think. A bit more. Then IPA dollop. Just got a bit of a clean, let it soak in for a minute, and then rubby. Okay, that's that one done. C113 is now protected. I'll do the other one on, I won't do it on camera, but yeah, you get the gist of the idea. Alright. Right, she's fully reassembled. The power is connected via a 60 watt light bulb. So the live feed, or actually the AC feed, comes through a 60 watt light bulb, so there's a short still on here. The light will light up rather than explosions happening, okay? And also I'm running from an isolation transformer. If you don't know what you're doing, watch out, because there's some very dangerous voltages on this side of the board over here on the power section, and it will kill you. And if you powered this up, these stay charged for some time, so make sure you take steps to discharge them. If you don't know what you're doing, don't power it up out of the case, alright? So it's all been put back together. And one final thing I was going to mention was I've just thoroughly checked all the solder joints I've made. At my old place, we used to have a red rack, where items like this couldn't be repaired by the experienced engineers. were put on the red rack for a senior engineer to look at, and I was that senior engineer for a while. And it's amazing how many guys had spent 2 hours on their sheet trying to debug something, and when I picked it up I just got an eyeglass and inspected it and found that one of the IC legs wasn't soldered properly. So, you know, they just think, always looking for the complicated problem. And the trouble is with these, if you switch them on without a soldered IC leg, you know, likely just go bang on you again. So make sure you check. I've got a spyglass and I have a really close look, and if I'm in doubt of any of them and I can't tell, then I just touch them up with some solder and flux. Alright, so do that because it will serve you well. That's any advice from this video you take away. Take that away. Check your solder joints on your IC legs, because experienced guys often don't, and that causes a problem. Alright, it's much easier to look at it and inspect it than to start poking around with the scope and a schematic and just wasting time and effort and money, of course. So anyway, without ado, I'm just going to rig up the power supply and we'll turn her on. Okay, moment of truth. Keep your mother on speed dial. Let's move these wires out of the way. You don't want these. These are for the front panel annunciator. I've put some tape on them. We don't want them floating about and shorting out on things. It's to power the little light in the front of the speaker, so they're not really to do with anything. It's just a resistor and a switch in that circuit. Okay, so we were dealing with the repair of this. You've seen the rest of this video, so you know what happens and where it happens and what have you. So turn it off there. Let's turn the power on. And so, I generally haven't tried this yet. It's always a bit of a nail-biting moment. I've got a 60 watt light bulb in series, you can't see that, and a power meter. So yeah, it's the old fun moment when you turn on your repaired switch mode power supply. You ready? That's the light we're looking at. If that comes on and we hear it click, we're in business. Yep. Yep. Look, lights come on. She's taking 23 watts at the moment, quiescent state, which is about right. God knows what the power factor is. I'll have to measure that one day. Yep, so she's working. I'm not going to bother testing the whole thing at the moment. I've got a separate video which I'm doing, which is the full functional test, parametric test of one of these things. And to go on this video has gone too long and I won't be able to upload it, but it's working now, trust me, I've done enough of them. I'll do a full test. Now if there's anything else, what I'm planning to do is, as I see different failure modes, I'll keep adding to this series of videos. So this is part 1, if you like, of the 315. And have a look when you finish watching this for part 2, right? And if there's part 2, if you do the basic repair and it doesn't work, have a look at part 2, because there'll be other nuances and extra information in those videos. Okay, so she's working. If you want to see more of this, and also to reward me, because it does take time, but I'm passing on this information because I'm going to retire soon, is just go down to that little button down there, that one in the corner, and just click it for me. Then you'll get an alert when a new video is uploaded. Hope you enjoyed that, and good luck with your 315 repair. Any questions, I check the comments up below the videos every day. I get a notification, and if it's not too much trouble, generally I pretty much answer all of them unless they're a bit stupid, in which case I generally don't bother. But if you've got any questions, happy to help, and there it is. So yeah, it's working. I'm going to leave this on for about 24 hours. Also I'm really going to stuff it back in the speaker, because this is my personal one, this one. As I say, I repair these for a living. That's just a roll of solder just to hold this up, keep this level. So anyway, hope you enjoyed that, and good luck with your repair. Any questions, let me know.